Hello everyone and welcome to this stream with DaShaun about multi-architecture. Now there's been a lot of talk in the community. There's been a lot of chatter across the world about multi-arch and what it is and what it can and cannot do and stuff like that. And so the folks that are part of the larger Cloud Foundry community, but also like the Buildpacks and other communities have been inquiring about this feature about can I work with Buildpacks on my Mac M1s? Can I work with Buildpacks and deploy to like Raspberry Pis and things like that? So we're very excited to see all of the work that's happening here. And so when you, DaShaun, and I'll let you introduce yourself in a minute, but when you had posted like a bunch of stuff about that you were experimenting with, I just couldn't wait to get you on a live stream and ask you to share about, what your experience has been so far with this technology, and just show us like a few things and also give us some perspective into where you think this is going in terms of a roadmap and things like that. So that is my big pitch for why we're doing this stream today, who our guest is, and why we have him here with us today. But before we can go to the business end of things, DaShaun, welcome. Very happy
Thank
to
you.
have you here. DaShaun is a part of VMware, and I'll let him introduce himself a little bit more.
Hi, my name is DaShaun Carter. I am a Spring Developer Advocate for VMware Tanzu. And before that, I've done a lot of cool things. I worked at Redis. I worked at Pivotal back in the day. And yeah, I've had a nice long journey. And in that journey, I've made many, many mistakes. And today I'm deliberately practicing to build, run, and manage better software faster. And I like to explore. So thanks you so much for just having me. Like I gotta say, I really like everything that you're doing around Cloud Foundry. I'm a Cloud Foundry fan. I was a happy Cloud Foundry customer. I did some really amazing things on top of Cloud Foundry, and I'm still amazed at all the things they can do. We just got done, talking about a story like, hey, I kind of stepped away for a little bit. I hadn't taken it for a spin in a while, and I'm amazed at how far it's come since the last time I looked at it. So yeah, things are really, really exciting, and it's a great time to be a developer.
Nice. For folks that weren't aware, DaShaun has always been a very active contributor in the Cloud Foundry community, not just technically, but he also served on like a program committee for one of the CF summits. And I think that's when I first met you. And he's like he mentioned, he's always experimenting, trying something new, and he's been very regular in terms of documenting what his findings are, and which is something that as a community manager for the Cloud Foundry community, I really value and appreciate you taking the time to document everything and make it available for the community at large.
I'm working on it. I'm getting better. Most of my stuff lands in a GitHub or a GitLab repository somewhere. I'm not as great at writing the good write-ups like you are, but I'm working on it. I'm trying to get better. I'm practicing at doing a better job of kind of explaining the cool Git repository. But
Right,
yeah, it's been fun. It's been fun.
right. Um, One other thing before we begin, are you also looking to be contributing more actively in the Paketo community as part of the steering committee?
Yes, I'm starting a campaign.
Yes.
There's an election coming up for the steering committee or the steering board, and I'd like to be a part of it. I realize I have a lot to learn.
Hmm.
I've been contributing. I'm a strong believer, and you can contribute to open source in so many different ways. We had this conversation this week, whether it's just as easy as a star. Like, tell the people that are doing the stuff that you like, put a star on their GitHub repo. Like,
Hmm.
that helps people know that they're going in the right direction. They've got a product market fit, etc. But opening issues, documentation, giving feedback. I expected this. Instead, I saw this. Here's my issue. Like, open that this is what I got. But there's a lot of ways of being a contributor to this open source ecosystem beyond just code and delivering features and stuff. Um, and I'm just at that point where I think it'd be nice to be involved a little bit deeper. I realized last week that the way that I was delivering this ARM64 build pack that we're going to talk about, the way that I was delivering it might not have been the best way. There's a better option for where I should have been putting this. So I'm working to move it there. There's a community space. So, and a lot of organizations have this, and I knew this. So I was like, oh, absolutely, I should have put it there. So I'll tell a little story. Back in 2000, the pandemic, et cetera, and there was a state in the United States, New Jersey, was having a problem getting their relief out, the unemployment stuff. And somebody in the state said, well, all of our systems are running on COBOL, and there's no COBOL developers. Build packs were a thing. The cloud native build packs were kind of new, right? This collaboration between Heroku and Pivotal created this new cloud native build pack. And I understood build packs. I was a big fan of Heroku back in the day. Again, I was a happy Cloud Foundry customer. I understood build packs. I did not want to use Docker files. But then there's this COBOL thing. And I'd worked with a lot of customers trying to move workloads off of the mainframe, which understandable, right?
Yep.
So me and a coworker, we decided to go down this little journey. Let's build a build pack for COBOL. Just see what it takes. It was not a language that we understood. And the cloud native build pack was new.
Right.
But the documentation on buildpacks.io was so good, it was easy. The hardest part was finding a COBOL, a compiler, a version to use that was open source and that I could leverage. But the COBOL community is a little bit different than the Cloud Foundry community. One of the things that I found in the Cloud Foundry community was it's open and it's inviting, and there's a lot of collaboration, and there's a lot of ways to do things, and people share it. Right? People share their views back. Well, anyways, I ended up building the cloud or the COBOL build pack based on the Cloud Native Build Packs specification, and that was it was a fun thing, and it worked. And I shared it with the COBOL community, and I made a GitHub repository for it. But what I should have done is I should have put it in the Buildpacks community, the Paketo Buildpacks community page, because it works. It works. I've seen others copy it and use it on their demos and stuff, so I know that it works. And yeah, it's just a good example of what I should have done.
Right.
Well, later I did this ARM64 build pack, right? When the Spring Boot Maven plugin started providing that feature of making a build pack, I was very interested. I was like, oh, what would it take? And I called in to whatever the live stream, or I sent a text message to the live stream, and I asked the question, like, what would it take to do this on ARM64? And I got an answer, and I was like, oh, okay. Well, I did it like my way. I did a really ugly like build out way just for my Raspberry Pis.
Sure.
And later I found out that, hey, Daniel Makusa, he kind of gave like a Paketo approach of like, here's the steps that you would do in order to replicate the Java build pack. And I was like, okay, well, this is good. So kind of scrapped my bash and duct tape way of doing it, and I followed along with his way.
Nice.
And with that, I actually started putting out releases. I put them into Docker on Docker Hub. And to my surprise, people actually started using them. So things got really interesting with Spring Native, along with this Spring Boot Maven plugin that I was using. But then all of the buzz around Spring Boot 3. Like Spring Native was like one step towards doing this ahead of time compilation that allowed me to build resources for an ARM64 architecture. But with Spring Boot 3 coming, it got a little bit more exciting, and there was a little bit more adoption. People were more interested. And I wasn't really expecting it to get as much use as it did. But I understood the value of ARM64 over x86. Like just in my home lab, just here. Um, I had the big racks that were supporting my Cloud Foundry on VMs, and I had two foundations, if you will, on
Okay.
two different networks, and I was doing interesting things. But one of those foundations, one of those clusters was running at 1.5 kilowatt hours at idle, and I was kind of not wanting the extra heat, not wanting the extra overhead, so I donated. I gave back to the person
Okay.
that gave me a bunch of that hardware. I gave back the hardware, and I really switched it to Raspberry Pis.
Okay.
I have tons, dozens of Raspberry Pis around my house for different things. And Raspberry Pis in itself is a very interesting space. You can do a lot of cool things. I've been messing with Raspberry Pis for years, for about 10 years now. And a lot of the fun little experiments, they were done with Python or Bash or some other language on these Raspberry Pi devices. And what got me really excited was that I had this cluster of Raspberry Pis. I could now do Spring, my favorite language. I could deliver Spring workloads as static native images on a Raspberry Pi cluster. I could do these cloud native, like enterprise type things with my favorite language. I didn't have to do Python. I could compile it and I could run it on these devices that only have a half gig of memory.
Right.
And that got me so excited. It got me really excited. And yeah, so there's a whole bunch of things that have kind of played into this multi-architecture future that we're in. The other is our clouds, right? Our cloud providers and
Correct.
our hardware providers. There is a very measurable value in taking some workloads from x86 over to ARM64. There's
Right.
tons of write-ups about it. The one that really raised my eyes the most was one from Honeycomb, where they said, hey, yeah, all we did was move these workloads from x86 VMs over to ARM64 VMs, and we saved this much money and we got this much better performance for these workloads.
Right.
So it's not going to be the same for all, right? But you have options. You have more things to think about these days. A lot of workloads, a lot of the Docker images today are being released as multi-architecture images. That's something that's been around for a long time. The capability of doing that has been around for a long time. This Docker manifest. In the manifest, it says, hey, if you're on an x86, I'm going to give you the x86 version of this. If you're on ARM64, I'll give you the ARM64. But it's not just those. Like, I'm actively excited about RISC-V, an open source architecture that you can implement with no license attached to it. So, and that's coming along. So just like my little Raspberry Pi, I now have these small RISC-V devices.
Okay.
And just the implications of an open source architecture. And we have conversations about the open source firmware. And open source is an important part of technology today.
Right.
So it's exciting. So as soon as ARM64 gets up and adopted, I will continue to work and make the same things happen with RISC-V, only because the team at Oracle working on Graal VM, they've made it possible.
Right.
They said, yeah, we think it won't take that much. And, lo and behold, they've released, now they have support for RISC-V. So I can take and compile my favorite Spring workloads, not just for ARM64, but also for RISC-V, and have them running on these, low budget single board computers.
Nice. Yeah, I think the conversation started to dominate when all of these individual pieces were happening independently, but when ARM64 became a thing with like M1 and M2 on personal devices, and then with Gravitron and these other instances on the cloud, and Raspberry Pis and all of these other smaller devices commercially. So I think independently all of these were just silently moving, but then once all of these three happened, and we just couldn't ignore the chatter anymore, and well, here we are. So now that you've introduced some of this stuff, anything you want to show in terms of like a workflow or your repos or?
Uh, I want to talk a little bit more.
Sure, let's do
One
that.
of the one of the things that I've, because ARM64 is so prevalent,
Mm-hmm.
um, it's a question that I ask. Do you have ARM64 support? Another thing that happened over the last couple of years was like, I was working at VMware. VMware has now this thing, so we can run VMs on ARM64. That was super exciting.
Yeah.
That was super exciting. So now I can have a lot of the same infrastructure. I can manage things the same way that I did, but literally on these Raspberry Pi type devices. And it's expanded. So another thing has happened. The introduction and adoption of these Apple M1s, more and more teams, M1 and M2s.
Yeah.
Right. I'm always reminded,
Yeah.
like this new future with the better battery life. Right. My colleagues and my peers, they're not even bringing their charger to the conference. Like, what are you talking about? Well, it's an M1.
Yeah.
It's going to last all day. I can do my demo and everything. I'm like, well, I don't even understand.
Yeah.
I don't understand what this is. But there was a point fairly recently where I'd released this image and what this image does. So let's talk about it. It allows me to build a native image on an ARM64 machine, so on an M1 machine.
Right.
And those native images are smaller footprint, but it's specific for an architecture and an operating system.
Right.
So if I build a native image for a Mac M1, a Darwin ARM64, it'll only run on Darwin ARM64.
Right.
But the Buildpacks, we're typically building for Linux and then the architecture. So when I created this build pack is going to create a image for Linux ARM64. So the upstream Paketo build pack built for Linux x86, but because it's in a OCI image, open container image, it can run on anything that's x86.
Correct.
M1 has this capability of running x86 workloads, but it uses emulation.
Correct.
So wasn't really a big problem. At first, there were some Docker issues and we couldn't make it work, but they got it figured out pretty quickly. And those M1 machines were able to run these x86 images. But not always the same. What if I want to build? I want to use that Spring Boot build image on my M1 machine, and it was hanging. The emulation and what the processor needed to do in order to build the AOT images, the native images, it would just hang. In most scenarios, it would just hang, and it would hang for hours. And hours, I mean, I waited, and 10 hours later, it's still just hanging. I wanted to see what would it eventually finish. When I first started building these, I believe the first one, I think I may have a document. I think the first one took like 24 minutes to build, and I was building it on a Raspberry Pi. So my loop of testing and validating these native images was long and boring. So I wasn't really getting excited about creating new releases. But my colleague, Lee Kapili, he actually said, hey, did you know that Oracle Cloud has a free tier that's really, really generous? And they've got ARM64 images. I was like, no, I did not. Thank you for telling me. He goes, do you know what else? I've got a repository that has Terraform that will stand up one of those images and it'll connect it to your VPN on Tailscale. Like all automated for you, like out of the box. I was like, what? So you're telling me that I can go and grab your repository and I can deploy a VM that'll connect automatically to my Tailscale VPN? It'll seem like it's part of my environment? He said, yes. I was like, what? So now, no longer is it taking that long to build the build pack, but I could build the build pack on a fast machine, and then I could build these images on that machine. So my process got sped up. And then you bring in the work that Daniel Makusa did, and now I've got I can actually put out releases. So now there's this process of putting out releases, and I've got this. It was still awkward, right? Okay. Nobody wanted to go on stage and deliver this build pack that was named DaShaun Builder. Nobody wanted to do that because it kind of pulled away. Like, what does that mean? Who's that? Well, I can't get support for that. Had I made the decision to put it into the Paketo community build packs, I bet you it would have gotten adopted a lot more.
Sure.
So this is a lesson, again, hindsight 2020, wouldn't it have been a great idea to do that? So that's why I'm doing it now. It's never too late. Best time would have been then.
Yep.
Second best time is now.
No. Yeah.
So let's go and move that. So we're taking baby steps in this direction. But what it gives is it gives people an ability to build those native images locally. Now, the big thing that I believe is going to be happening, I believe there's going to be a massive change in the way that we're building things. We're still recovering from this pandemic. And the way that teams are organized is still, there's no answer, right? Things have changed, but we don't know changed into what yet. Things are definitely changed and still changing, but we don't know into what. So one of the things that has changed, one of the other things, not just in where we're at and how we're developing, but I always ask, like, where do you run your tests? Where do you validate that your stuff works? I ask that. I try to get a sense. There's still a lot of people that are developing on a remote computer. Like some institutions, you can't bring your work home.
Right.
You can go home, but you still got a VPN in, and that code doesn't leave. So you're going to get an RDP or VNC session into our protected environment, and that's the way things are. Understandable. I can't imagine how fast they're going. Like I like to move. I like the dopamine. I have to have dopamine. Mean time to dopamine. I have to have it. So I just ask, but there are a lot of people that are still developing locally. But then the question is, does your local environment look like production? The thing that I got most excited about on your session. I can run locally. Again, I was a Cloud Foundry fan for many, many years.
Right.
But the thing that was so difficult was, how do I get that Cloud Foundry experience on my laptop?
Right.
And, when I was, using it, there was no such thing as a 64 gig laptop.
Right.
So even if I was using the one-offs, the CF Dev or PCF Dev or whatever, even if I was using those tools, not a lot of people had the horsepower to make it valuable.
Right.
So it was a problem. And I ran into that all over. Oh yeah, it sounds great. Where do I download it so I can play with it on my laptop? There wasn't an option.
Correct.
But now there is. Right? With Karifi, I can do that. I can have that experience, that local, boop, 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 I can go. That's valuable. That, if you've never done it, it's hard to imagine, but that experience of having a CF push locally is so fun, so exciting, so valuable that, once you try it, I think people will get excited about it. And this idea, so I've had large teams before, I've had distributed teams. And one of the things I struggle with is, how do I make sure that everybody's using the latest and greatest? Like they're not working against an old version and writing things they're just going to have to rewrite. So that releasing software fast, like that practice, is important. But as a developer, I also like to get the latest version. So if you and I are working on something, and we're at different parts of the world, I've dealt with the pain of getting the latest version. Doing just even a git pull or git clone across the globe is difficult. So how do we make that better? Well, one way is with these native images. So the native image, that statically linked native image, let's do a demo. Let's do a demo. Let's talk about this. So give me 1 sec. I will try to do this. Yeah, let's do this demo. So this is just Spring Boot, and I'm going to show a couple of extra things here because it's interesting. And this is just an upgrade. So I'm a Spring developer. I'm doing things. I make sure that I have Java 17. But then what I'm doing here is I'm just using the actuator, and I'm building a Spring Boot 2.7.9 image.
Okay.
Cool. It's got the web and the actuator. That's all it's got. I do a git in it here. But now I'm just going to run this, build it, right? As a developer, this could look, many, many different ways. I might just run it in my IDE. There's lots of ways for me to do this. But this is all I did was take a Spring Boot image. I grabbed it from start.spring.io.
Yeah.
I'm doing it as a command line. But just build it, start it. I did quiet so that we didn't see all the logs. But it's a 2.7.9. And the thing is, it starts up in, this number is 2.401 seconds or 3.117 seconds, whatever one. I grab this process ID. I hit the actuator endpoint to make sure, yes, it's up. And then I grab this process ID and I say, hey, how much memory is it using? 169 megs. Cool. And then I just stop it. So these logs are nothing. It's just I killed the process that was running in the background.
Okay.
I'm going to keep on going. So now I'm using an open rewrite tool. Like, this is just the way that I like to build. This is one of those things. Like, hey, as new versions come out, Spring Boot 3.1 is right around the corner. The RC2 version is released. Spring Boot 3.1.0 is right around the corner. I'll be able to go and grab this recipe, and I'll just be able to upgrade my project to the new version. So this is just a plugin that I'm running against the project that I just built. First thing is I wanted to upgrade it to Spring Boot 3, and then I said I wanted to remove duplicate dependencies. Easy peasy. But I'm not coding that thing, right? These are just things that might be a part of my pipeline.
Right.
Might be a part of my CI/CD process. Just make sure that I'm on the latest version of Spring Boot 3, make sure that everything is coming through, doesn't have any duplicate dependencies in the POM file. Easy enough? Cool. Now let's just rerun it. So first one was Spring Boot 2.7.9. Okay. Could have been older and we'd upgrade. This one, now we're at 3.0.6. I didn't modify anything. It was the plugin that did it. I do the same steps, like, hey, hit my actuator health endpoint, make sure it's up, grab the process ID. Hey, this time it's running 214 megs max. Cool. Oh, and the startup time, 3.18. So similar, not a big difference.
Yeah, no big jump.
And then I stop it. Well, the next thing, now that I'm in Spring Boot 3, I can do some interesting things. So this is actually on a x86. Okay. But I'm doing this native compile. This is going to take a long time. So what this whole thing, what this native compile is doing, is it's going in and it's building my Spring Boot application. It's looking at all the different places that the code could go. This is what Graal VM is doing against my Spring Boot application. It's checking out all the different paths, all the different branches that could get executed. If I'd thrown in a generic dependency for Kubernetes, a Kubernetes library that I'm not using, the Graal VM is going to be like, oh, you don't need that. All those extra dependencies that might be on the class path, it's going to say, yeah, you don't need any of that. You're not hitting any of that code, so get it out of here. And it's analyzing. And this is going to take minutes because I'm also streaming on this machine. It's going to eat up all my processor. My span's spinning up. It's doing all the things. And it's analyzing as much as possible any of those branches of code.
Okay.
Now, the Graal VM has been around for a long time. It's gotten faster over the years. Spring team said, hey, with Spring Framework 6 and Spring Boot 3, we're going to require Java 17.
Okay.
So we rebased. You've got to use Java 17. With that, now you can use Graal VM as one of the things, but also the naming conventions around, Javox to Jakarta. There's a bunch of naming changes, some other things, but we want you to be on Java 17 so we don't have to deal with that, and we can do things going forward. So hard stop, cool, rebase to Java 17. Easy enough. There's plugins that'll help you. Most of your IDEs will help you do that upgrade. So that's easy. But now we have this other capability that we can do. The Spring team also made it so that all of like the reflection that we use in Spring, all the things that make Graal VM, make it difficult for Graal VM to do its job, the Spring team put in all of these hints so that the Graal VM knows where to go when it runs into something like reflection. So it can analyze all the places in the code that it needs to go. Okay. So now that's the way it is. It's supported across all of the Spring-driven projects. There's still some that are working, but the Spring team has contributed all of that metadata that the Graal VM needs. Okay. Yep, out into the public. So now the Graal VM can go and look at this metadata repository and figure out all the things it needs to do. And it makes it really easy. But upgrading to Spring Boot 3, a lot of your projects are going to have a really easy time. Now, here's the thing. If you were on M1, we wouldn't get this far. Using the build pack, even the native compile, you wouldn't get this far because of the different architecture. So what do we do with the build pack? So I pushed out this build pack so that I could do this on M1. I did it so I could do it on Raspberry Pi, but now I've made it possible for the M1. And I pushed it out there and like, hey, yeah, you can use it. Go have fun. But then people started using it. And there was a point in time where in the same weekend, Josh Long, Spring Developer Advocate, he's a universe, and Oliver Dropbaum, they both ran into an issue at the same time on their M1, and it wasn't working. And I was like, oh, what am I going to do? There's actually people using it, and now these people are complaining. There was, hey, it's broke, and I got a Slack message. What do I do? I was traveling. The day I got back, I didn't have an M1. All I had was Raspberry Pis.
Right.
The day I got back, I went to the store. I bought an M1, and I was like, I got to fix this. It was a Friday when I bought it, and I worked on it all weekend to get out a new release, and I didn't fix anything. I just grabbed the latest version of the upstream build pack and created it for ARM64, and it fixed everything. I don't know what the problem is still today. But I fixed it. I got a new release out on Monday, and it fixed everybody, and I was so happy.
Right.
And at that point, that whatever version that was, I think that might have been even like it was like a year ago.
Okay.
Like it was before Spring Boot 3 even came out. We were still doing this on Spring Native, working towards the Spring Boot 3 release. It was a year ago. But at that point, that build pack really kind of took off. It went from like double-digit numbers download. There's whatever, 20 or 40 downloads, and it really kind of skyrocketed after those releases. So what I did here, that native compilation, you can see on this machine, it took 3 minutes to do. So don't do this in your inner loop cycle. But again, it's still my same running the native image, running it in the background.
Okay.
And then I hit the actuator health endpoint. The first thing is like that same app, it started up in 0.151 seconds. So from 3 seconds down to 0.151 seconds.
Right.
This is exciting. Then, I grabbed that same process ID. Yes, see, it shows it's up. But I grabbed that process ID, and it only takes 37 megs.
A fraction of
wow, right?
what it was.
So from 100 something or 200 something megs down to 37. So everybody that's running Cloud Foundry, and this is where it got really interesting. Everybody that's running Cloud Foundry today, running with Spring Boot workloads, has this option of going and taking your same artifact, take the same workload. Actually, I have another thing I can show. So this is what we're talking about. That image, I can even go in here. Let's go and look at upgrade example in the target, like the class, the thing. So look at here. The jar file that we built was whatever, 21 or 211 megs. What is that?
Yeah,
21 megs.
Yeah.
All right, but the demo, the statically linked binary, it's 68 megs.
Right.
But DaShaun, you said it was going to be smaller. Well, here's the thing. This demo doesn't need the JVM. It's made for Darwin x86. That's what this machine is.
Right.
It'll run on any Darwin x86 machine. Now, the jar file, again, that's a jar file. You get a JVM, it'll run on any JVM. No matter which operating system, no matter what architecture, it'll run on that JVM. And that's cool. We have that. But sometimes this is actually more performant. We see this, the footprint is smaller for sure. Right? That startup time, that's going to matter for a lot of workloads.
Correct.
Right? That's going to be big, your serverless workloads. But let's just stick with Cloud Foundry. You've got your Cloud Foundry. Doesn't matter if you're on Kubernetes or on VMs. You've got your Cloud Foundry instance. Now, let's think. You've got 100 workloads running on Cloud Foundry. What's a default size for a JVM image on Cloud Foundry? It's about 2 gigs.
Yeah.
Normally, when we're deploying a Spring Boot workload to Cloud Foundry, we'll do 2 gigs. If it's simple like this, maybe 1 gig. So I'm going to stop this share, and I'm going to open up another screen if I can find it real quick. But this it comes down to we've got an option. My Cloud Foundry foundation, where I'm deploying my Cloud Foundry workloads. It's got numbers, right? It's got some footprint, some number of VMs, and some number of workloads on it. I'm trying to find my my repository here. And I did this exercise with Nick. Let me trying to be super professional here and talk while I type, but I'm just not that smart. I'm not that good. So here we go. So I did this exercise.
Okay.
I went and I did the exercise we just did. Build a simple Spring Boot app. But what the outcome is I can increase the value of my Cloud Foundry foundation. If I can go in and take every one of those 1 gig workloads,
right,
and by converting it to a native image, I can reduce it down to a 256 megabyte workload. That's a 75% savings.
Yeah.
For every AI that's running that I can do this on, a 75% savings. So if I've got 100 of these 1 gig images running on my foundation, I can reduce the amount of memory that I'm paying for in the cloud or in the data center. I can reduce that. I can give 75 gigs of RAM back, however you want to look at that, if I go and take this step. This is exciting. Some of those workloads aren't just going to save me money on the infrastructure. They're going to give me a better performance.
Right.
Some of those workloads, they might not perform better, but the cost savings outweighs the performance difference.
Right.
So we have all these options. Now, we're doing this cool stuff. We can take it one step further. Now what we can do, this is where we get into the work that I've done. I hope that you can still see.
Yeah.
This is the Paketo ARM64. So what this is, I forked it from Daniel Makusa's work. I forked it. I was following. He had like a step. Hey, do this. He gave me an outline of what to do by hand.
Okay.
But as demand grew, the do it by hand, the value in that kind of faded, and I needed to like fix things for people. People were starting to use it. So I started to like, look at this. Like I get giddy. Like there are 24 people that said, "Hey, DaShaun, I like what you're doing." Like just that. That's motivation enough for me to keep on working on this and for me to push it upstream. But I've made many commits since this forking. I used to push back up, and I was kind of making his repository the main one.
Okay.
Because I was keeping up with the upstream build pack, and I was pulling in the changes and pushing it back up to his. But that got to be a little bit too much, and I got out of sync. So I was just like, oh, I'll keep on going here. I have a video here that kind of talks about the ARM64 struggle and how, hey, if you're on an M1, you might have felt left behind. But this is here to fix that. But yeah, it's great. People are forking it. People are using it. There's an open issue. But at some point, I got a little excited because what was happening was, in order to use my builder, if you were on ARM64, you used my builder.
Okay.
And you put in DaShaun/builder to get it. But if you were on x86, you were using the upstream Paketo Buildpacks builder.
Correct.
But that means that your GitHub repository had a big if in it.
Yeah.
So at some point later, we kind of collaborated and we took it one step further. So this concept of a Docker manifest says, hey, Paketo upstream created their Paketo Buildpacks builder tiny.
Right.
And it's up there and it's supported. Well, I made this DaShaun builder tiny that works on ARM64. The manifest that I created takes those two and puts them into the same manifest. It kind of glues the peanut butter and jelly. And it says, hey, I'm going to deliver this upstream manifest. So I delivered, now DaShaun builder is not a single image. It's a manifest that includes DaShaun builder ARM is what I named it, and Paketo Buildpacks builder. So if you're on ARM64, you're going to pull down DaShaun builder, ARM64. But if you're on x86, you're just going to pull down the Paketo Buildpacks builder.
Right.
And this is the diff. That's the whole thing. It's like the diff is like, yeah, mine's not trusted. Don't trust this one. It doesn't have any signatures or anything. But this side you can trust. Like, so it's
Sure.
cool. This is the supported side if you're on x86. This is the unsupported side. That's the diff. When you inspect those two images, that's the diff.
Okay.
Wonderful. So, yeah, I kind of go through the explanation here and show all the things, show the diff. But the whole story is on my DaShaun.com. And there's a bunch of videos on my YouTube. And it's interesting and it's been fun, but the story's not done.
Right.
So I'll stop sharing. Like this, I think says it all. And this is, we have a lot of Cloud Foundry customers, commercial on TAS and open source customers that are like, wait a minute, because here's the thing between you and me, like the secret is like, if I'm a developer and I find that I can go find 100 of these Spring Boot applications that are going to save 75% of their infrastructure costs, that's a good thing. Like if it all works and all your tests pass and you're in production and you just gave back 75 gigs of memory every month, you gave it back to the infrastructure team, to the budget, to the company that you're working for. Well, now you've got some credibility. You've got a little bit of leverage. Like you want to do something cool. You want to go and expand your Kubernetes footprint. You just found some budget to do that.
Yep.
Or at least when you ask, like, hey, yeah, I'm the guy that saved you, this many gigs per month on the infrastructure. I was wondering if I could maybe borrow some of that to do this experiment and go forward, like cheat code. So that's something very, very cool. But there's more. As a developer now, I've got this multi-architecture build pack.
Right.
So when I'm building things in my POM file, I don't say if I'm x86 or if I'm ARM64. I just put in DaShaun Builder Tiny, which we'll fix that upstream real soon.
Sure.
I put in the one image, the one thing, and if I'm on x86, it builds x86. If I'm on ARM64, it builds ARM64.
Right.
There's even a future where when I use this builder, that it builds both images, no matter what I'm on. Right? So the future that when I do a Maven Spring Boot build image, that I get an image that runs on ARM64 or x86 or RISC-V.
Okay.
All from within the build pack.
Okay.
That's an exciting future. We're not quite there yet, but it's not that far away, and it's easy, and everybody wants us to get there.
Right.
That's the future that I'm trying to work towards. So where I can take my Spring Boot, I can build an image just with my plugin. I don't have to do anything because I get the plugin. I get it when I go to start at Spring.io. I get the plugin that does all the things. And when I do Spring Boot build image, that OCI image will run on your M1, on your Raspberry Pi, on your x86, on your Ampere, your Graviton, whatever it is. That's an exciting future because some workloads, native compilation, right? That's going to save you a bundle, right?
Oh, yeah.
We saw that. But some workloads are not just going to save on that footprint. They're going to then save even more by running on ARM64.
Right.
Right? The honeycomb, I referred to that honeycomb article. They were saving, I'd say the number 33%. I don't remember what it was, but they were saving some non-trivial percent of performance on top of the savings. For those of you that don't know, an ARM64 image, a 4 gig, 4 core image or 24, whatever, X number of gigs, X number of cores on x86 is typically going to cost you more, some percentage more than the same number of cores, same number of gigs on an ARM64. And for some workloads, that ARM64 is not only cheaper, it's going to perform better.
Yep.
So this is the future where we've got another thing to think about. So there's another vector that we've got to make a decision on. I don't want to have to think about that ahead of time. I don't, but it would be nice if I'm building a Spring Boot app and I say, hey, here's my image, here's my container, go run it on the cloud, I don't care. It would be nice if I could deliver one image and let the platform, let Cloud Foundry decide where that's going to run. Because maybe my foundation at some point is mixed up with ARM64 VMs,
Right.
ARM64 nodes, and x86 nodes. I have done that in my home lab. I've had a Kubernetes cluster that had different types of nodes
Mm-hmm.
in the same cluster. And wouldn't it be nice if your platform, whatever it looks like in the future, could determine after some period of time that, you know what, this workload would actually run better on this type of node, this architecture, or this workload would actually save us money on this architecture. And to do that, it's another thing that we're going to have to think about
Right.
in the future. And now we have those options. So it's here, right? Whether you like to admit it or not, we are at this point where we are doing multi-architecture things. There are companies large and small where that 33% savings on the architecture type makes a world of difference.
Right.
Where the performance boost from changing architectures makes a world of difference. But also, it's not an all or nothing.
Right.
It's not an all or nothing. And we've known this, and we've been telling this story with Cloud Foundry for years. Like, not every workload is going to fit and run and be successful on Cloud Foundry. So you have to have options.
Right.
Right? You have to have options. But it's a better future. Right? We're in this spot where Cloud Foundry, I believe, what we're doing with Cloud Foundry is amazing and important and valuable. And there are so many workloads that are going to be successful and easier to maintain and easier to upgrade when they're running on Cloud Foundry. That developer experience I talked about, like what I want it to be on my laptop.
Mm-hmm.
That CF push experience locally is amazing. So without doing the native image, but just running that CF push practice, I can stand up entire big A apps, that has all the things in it. I can stand it up really easily with a manifest.
Right.
And when I switch projects later in the day, down, up, but I'm at a point where I can run that on my laptop, and that's amazing. This is the future that I'm excited about, and I want to share. I want developers to know how amazing it can be. I want 2023 to be the year of Kubernetes on the laptop. It works, but having that inner loop, that fast inner loop cycle can be valuable, and we can show. And we can have this local environment that matches our dev environment, test, stage, QA, prod, etc. That's valuable. And this is where we're at. Whether you're on an M1 or x86 or whatever comes next, RISC-V, we want to be able to support that future because there's going to be workloads that are going to get a lot of value out of these different architectures. I had fun just going through that because I still get giddy. I still get giddy. What questions come to your mind?
No, I think a lot of the stuff is covered, but the big question that I have is, does this kind of work then mandate a lot of changes in the kind of infrastructure that we have in place in order to be able to build these multi-architecture or like a composite architecture image? And then I'm wondering, what kind of time investment would folks need if they have to start changing their build pipelines, let's say.
So the nice thing, this feature that we talked about today, I've got examples in my GitHub repository. Actually, let's show one. Where I'm kind of doing the same thing that I've done for the Buildpack. Like, hey, build two images, glue them together to get a multi-architecture image. And this is just GitHub. Here's an example where I've got a Circle CI. Circle CI has ARM64 builders. So I talked about that Oracle VM. I don't use that Oracle VM anymore. I use Circle CI. Circle CI has these ARM64 builders. So here it goes out and it builds an ARM version of this OCI image using the same command, Gradle W boot build image, but it's on an ARM64. So the output is an ARM64 image. So it does that. It puts it into my repository with a -ARM64 label. And then at the exact same time, when I do my commit, it does the thing. It goes and it runs an AMD 64 version.
Okay.
Exact same process, except this is running on an AMD 64 runner in GitHub Actions.
Right.
But it runs the exact same command where is it here? Great old boot build
Yeah.
image.
Yeah.
And it spits it out with the label. It gets the dash AMD 64.
Uh-huh.
But then in GitHub, it creates the manifest. So it
Mm.
says, hey, go grab the ARM 64 version. Let me slide over here. Go
Okay.
grab the x86 version and grab the ARM 64 version, the AAR64 version, and slap them into a manifest without the classifier tag.
Okay.
So grab the AMD ARM 64, slap them into one that doesn't have the extender. So now you have a multi-architecture manifest that you can pull. So if I were to
Mm-hmm.
use this image, all I have to do is grab DaShaun Dev Service Gateway latest. And whatever machine I'm on, I'll get it. So that's how we can do it today. That's how I can deliver. So where you do your build of your image in your pipeline today,
Mm-hmm.
all I'm doing is saying build 2 images. And then when those are done, squish them together
Right.
into a manifest. There's even like a retry, like, uh, the ARM 64, it might take longer or less. Like, so yeah,
Yeah.
hey, just wait until they're both done and then slap them together to get your image. But then the rest of your pipeline looks the exact same because you're using the same image. The artifact is the new thing. It's a OCI image. That's the artifact that we're using. So you can go scan it, scan the source, do all your things, sign it, and deliver it just like you normally would. That's the only change that I've got to do today is I'm
Okay.
building to slapping together and going. But there's a future, not too far, easy to imagine, where my build pack does all of this work.
Right.
My
Right.
build pack creates both versions
Right.
and does all the glue together so that when I'm done building my build pack, boom, I've got a multi-architecture. And maybe it should be a flag. Maybe it should be an option. I don't know, but that's why I want to be on the steering committee. I want to be a part of the conversation because they've got this experience of building, running, and managing these things far beyond it. I'm just I'm coming in from the developer side, the developer experience side.
Right.
And I think it's a great point in time. We have a lot of really cool things that we can do, and the future looks amazing. So that process today can be done. And here's what that means for you and I. It means if I did this as a native image, I can take a JVM image. So now here's the other thing. I can take that JVM image and still run that in production because maybe that performs better. But for us, for dev, on my M1, I can be sending native
Right.
images for
Right.
your M1 or for my x86. I can be sending those across the wire, and they're tiny.
Right.
So you don't have to go and git pull and do a build on your local box. You can just get the image, the latest dev image, and it can be from main or from a dev branch or whatever, and they're easy to ship around the world. Because when I'm shipping these OCI images, it's only going to ship the layer that's changed,
Right.
and that's magic. So this is another point in what I can be doing locally and this experience that I can have locally where I can have the entire system. I can get traces across all the different things and with real data on my local box. So I can have a real local environment that matches my production environment.
Got it.
And that's exciting for me. For the way I develop, that's exciting. And I can do a lot of really cool things. I hope I answered your
Nice.
question.
Oh yeah, absolutely. Yeah, the possibilities really are, very exciting, and I'm happy to, be a
Yeah.
be a part of um, the community that's doing all this,
Yes.
and taking the message across to all the people that want to know this. Um, so we
So another thing that I've learned, a lot of the tools in Kubernetes, in the Kubernetes space, a lot of folks are using Go.
yeah
And Go is great. And Go, again, I'm not going to go into the language, but I find many, many times that delivering things for ARM 64 from what I have is easy. Like Go makes that easy, where I can deliver multi-architecture releases. And that's why this possibility of spitting out multi-architecture images is a possibility. Right? Well, there's still work to be done, but it makes it seem like it's a possibility. But a lot of the fear and concern that I had with like, how am I going to do this? And it's so complex. Compiling things for ARM64 is not hard. Just a couple weeks ago, I was at that point where I'm trying to use Daniel Makusa's multi-architecture stack. He took it a step further. In my image, I was using an x86 or an ARM64 image. I was building my own stack. And he made it so I don't have to build my own stack. Now there's a multi-architecture stack. So the images, the underlying Ubuntu images are already multi-architecture. So your runner and your builder, that's already available. So my process of building that multi-architecture builder got simplified. I don't have to build the stack anymore.
Right.
We're getting closer and closer every day.
Right,
But
right.
in the process of building my new multi-architecture build pack to use his multi-architecture stack, I was going to need a multi-architecture jam, one of the tools that Paketo team uses to build these images.
Yeah.
I said, hey, I'm stuck. The next day, I didn't even open the issue. The next day, it was already there.
Okay.
Just from chats across the different image problems, different repositories, the next day, like I thought about it. I wished for it. I was planning on writing the issue, and it was there before I even got a chance.
Right.
That's how fast we're moving.
That's great feedback, I think, to all of the core contributors and maintainers as well. So, yeah, I think we're almost out of time. Thank you very much.
That's a bummer. I could talk with you for hours. You let me talk. You let me ramble. I wanted to say again, thank you, not just for hanging out with me today. Thank you for the Golden Path session that you did. It was awesome. I'm sharing it with everybody. And also just thank you for being a part of the community, an awesome part of the community. You're doing great things, and I'm a huge fan.
Thanks, DaShaun. Yeah, thank you for taking some time out and all of the efforts in the past weeks and months, years even, and being an active part of the Cloud Foundry community. So for those folks who are following, I think you picked up the link to the GitHub repo that DaShaun was showing. So do check it out. I will drop those links in the description that's below this video. So people who might watch this in future can get access to that. And we have a bunch of very exciting live streams coming up. So do watch out this space for more information on that. There's also a shout out to Cloud Foundry Day, where we have a bunch of Paketo talks and a bunch of other Cloud Foundry running at scale presentations. So the event is hybrid one. The physical location is Heidelberg in Germany. I hear it's a very beautiful city, and we're going to be there at a wonderful time of the year. So we're there on June 21st, and so folks who are able to attend in person, please join us. You're most welcome. Folks who are able to attend virtually, the registration is available on the Linux Foundation events page. So do check it out, do register. And the Paketo repos are all on GitHub as well, and so are the cloud native build packs and all of the fun stuff that the different conversations today have been based on. So lots of open source goodness there.
Yeah, so my focus was on the Java and Java native build packs.
Right.
But if anybody out there is wanting to do this same exercise, right, this is just kind of the start. This is an example of what it could be, what it could look like upstream with Paketo. If anybody else has another build pack that they are interested in making multi-architecture, please reach out. I am happy to help and share the lessons I've learned. Again, I would love for this all to be upstreamed in Paketo and have this feature where the multi-architecture build pack and multi-architecture OCI images, that's the norm. Happy to help.
Cool. And don't forget, DaShaun is running for the steering committee election, so any support that you can show him is much appreciated.
Yeah, wait, I even had a tagline. What was my tagline? It was like a better build packs. I gotta find it. My tagline for my campaign tagline. Let me see if I can find it. I said, embracing multi-architecture build packs for a brighter, inclusive future.
Nice.
There it is.
Thanks so much, DaShaun. I think that's a great note on which to conclude today. Thanks everyone for watching.
Thank you so much.